Right. This video is going to talk about negative externality, a topic from chapter 7. And negative externality is also the way that economists understand pollution. So this is our model to help us think about pollution and understand how and why it's a problem. So the name negative externality is going to suggest there's going to be some spillover or third-party cost. And by third party, the first two parties of any market transaction you can think of as the buyer and the seller. So they're the first two parties. So when we say third party, we mean somebody else other than the buyer or seller in the market transaction. And if you, a lot of people might come together on the seller's side. There'd be people who are working for a business or selling them products or inputs that they use in producing something, supplying their companies. But that's okay because they all come together and somebody produces a product and that seller sells it to the buyer. So the buyer and seller are the first two parties. What we mean now is any kind of a cost that's going to spill over to a third party. So let's take the case of driving. So what we think is like we had to have a supply curve for driving, the cost of driving. And that would include like the cost of a car and the cost of gasoline to power the car if it's a gas-powered car. And then everything else that would be involved with driving a car. Those costs are what we call internal. We haven't used this term before, but we've talked about the cost of doing something. We've always been talking about the cost that suppliers would have to bear to supply goods. So there's a cost of driving and that drivers have to bear. But as you drive a gas-powered car down the road, some exhaust comes out of the tailpipe. And some of that exhaust includes some chemicals that can impact air quality. So in effect, as you drive, not only are when you think of the costs of driving, the costs of driving not only include the cost of the car and the gasoline and all those costs, it's the cost of damage to the environment. Another way to think about this, if you want, is to say that when you drive, you're using some clean air as an input in the production of driving. It may be a weird way to think about it, but if you think about it, what I think is good about that is that that's an input. We're using that input, and it's a scarce resource. All of our resources are scarce. And air that's used as an input in driving, in other words, that we use it to dump the car's exhaust into the air, we can't use it for something else, like for, say, breathing, or if we breathe in air that's got pollutants in it, it could cause some health problems. So when we think about it, the internal costs, the costs that people normally have to pay to drive, don't include all of the costs. There are some additional costs that are external, that the demand that the buyer and seller do not have to incur. So they're external. So this supply curve doesn't represent all of the costs. We have to draw a second curve or adjust this curve to show the external costs. Well, in chapter 3, when we introduced the supply curve, we said one of the things that could shift the supply curve would be an increase in input prices, because that would increase suppliers or the cost for suppliers. If you had an increase in input prices, you'd shift the supply curve to the left. There'd be a decrease in supply. And when you shift a supply curve to the left, then it's also sort of shifting up. So that's what we've got to do. We draw a second supply curve to reflect then the external costs. And we label that the social cost. So that's the social cost. That's the supply curve reflecting the social cost. All of the cost, the full cost of producing, all of the value of all the scarce resources that we have to give up to drive. And so we have this relationship. The social cost would be the internal cost plus the external cost. So that means if we're looking at a graph like this, the vertical distance between the internal and social cost curves, this would actually be the amount of the externality. The external costs are here. They're represented in the distance between these two curves. Okay, so we have that. So that's how we want to think about the externality. Now, all we have to do is think about equilibrium and efficiency. Well, Equilibrium, we'll say, is where the supply curve intersects the demand curve. That's what we said back in chapter 3. Now we have two supply curves. So which one do we use here? Well, we're going to use the internal supply curve because that's the cost that suppliers have to pay for. Those are the costs that suppliers have to cover in producing the good. The third party or external costs fall on those third parties. Suppliers don't have to take them into account. So equilibrium is going to be determined by the intersection of the supply curve that reflects the internal cost and the demand curve. They intersect here, so I've labeled PM and QM. Those would be the market price and quantity. That's the equilibrium price and quantity. Now we have to think about efficiency. Well, efficiency, we're going to use the social supply curve because when we talked about efficiency, introduced efficiency in chapter 5, we said that you had to take for a consumer producer surplus, it had to be the area that's above the supply curve because the supply curve represents the willingness to supply. But it was also another way of saying it represents the opportunity cost, the full cost of supplying the good. The external costs are real costs. They are real costs. They are scarce resources. We're using clean air. We're polluting clean air, so we're in effect using clean air to drive. We have to include that cost in the full cost of driving. So we will use the intersection of the social supply curve and the demand curve to give us efficiency. Where those two curves intersect is here, and this would be the efficient price, or the efficient quantity. Now what we can see is that the market quantity is greater than the efficient quantity. So this is a case what we call market failure. We refer to this as market failure. Market failure because the equilibrium quantity, the market quantity, is not equal to the efficient quantity. In chapter 5, we saw that normally with a market, in other words, when there's no externality, the market quantity is going to be efficient. So too much of this good is going to be produced. Another way to think about this is we have too much pollution. As economists look at it here, the problem is that we have pollution, but we have too much pollution. We would say, well, the driving is valuable. People need to get from one place to another. And we use lots of scarce resources to produce the goods and services that we want to consume because they're valuable enough to us that that what we're consuming is worth using resources for, including possibly using clean air. If we want to use clean air or other things in the environment, if we want to pollute some water to dispose of some nasty chemicals, then that's a use, and we might choose to do that. So it's not that we have pollution, but we have too much pollution. The fact that we have that this market quantity is greater than the efficient quantity is leading to too much pollution. Another way of thinking is I drew, here's the price that we would need to have if the market, if we were going to have an equilibrium at Q at the efficient quantity here. So the intersection of the demand curve and the social supply curve. So that would be, in effect, the price we would need to have. But that price we see is greater than the market price. So another way of thinking about it is that when we have pollution, the price of the good is too low. It doesn't reflect, the price does not reflect all of the costs. At the market equilibrium, they're only paying for this portion of the cost. There are these extra costs, these external costs that the market price is not covering. The market price is too low, it's not covering all of the costs. Another way to think about this is the external cost, it's the externality that's the problem here. We could take any component of a supplier's cost, of the cost of producing a good. And if we said suppliers don't have to pay for this, we'd have this exact same diagram. So if we said like, oh, automobile companies get to take tires for free, right? They can just like go to Firestone, Bridgestone, whatever, say we need some tires to put on our cars, we're just going to take them. If they could do that, then we would have some external costs. The price of cars wouldn't have to, and the price of cars and therefore the price of driving wouldn't end up having to cover the cost of tires, and we would have an externality. And so if you could use tires without paying for it, you'd have a similar type of thing here. So it's the externality that's the problem, not the fact that it's pollution per se, not the fact that we're using clean air as an input. We are not, you're using clean air as an input without paying for it. That's why economists, in the book they'll talk about, the solution, or the best solution is really to somehow internalize the externality. Make the producers pay the full cost. Make it's sometimes referred to as make polluters pay. Make polluters pay the full cost, because once they do, then the market prices would have to adjust to cover those costs. And then we would only we'd drive up to the quantity where the value of driving given by the height of the demand curve is greater than the full value of all the costs that driving is imposing. Another way to think about this diagram is, if we wanted to, we could identify an area of deadweight loss in the equilibrium. These units are being produced, but they are not worth producing. The height of the social supply curve showing us the full value of these units is above the demand curve. So we've got negative surplus here. We're producing too much of the good. We have a deadweight loss, and that deadweight loss would be this area here. If both the supply curve and the demand curve are linear, then this area is a triangle. So we have a deadweight loss, and that, just as we saw with a tax, just as we saw with a price ceiling or price floor. So we have a deadweight loss. The optimal, at the efficient quantity here, you can see there's still some what we call external costs at the efficient quantity. So another way of looking at that is, say, with efficiency in the market, the quantity of pollution, the quantity of exhaust put into the air is not going to be zero. So economists often say what others would think are rude things, like saying the efficient quantity of pollution is not zero. But we would say that that makes sense, because, again, driving is a valuable activity. The other things that we're producing are valuable things. They are worthwhile, and provided they are worth enough, then we should be willing to use scarce resources to provide them, including perhaps using resources from the environment, using maybe clean air or clean water as inputs in the production process. So that's pollution sort of here in a nutshell. We can say a lot more about this. I've taught environmental economics a number of different times, so I've covered, to talk about this kind of stuff for an entire semester. But we'll leave it here with this, because this is what we need for this diagram to be able to understand what happens in a market when there is some kind of spillover cost, a negative externality, and that's our take on pollution.